All right, today we're going to be learning about ocean acidification. You all have now learned about acids, you've learned about bases, you've learned about pH, and now we're going to see where this happens in real life. A lot of times kids say, yeah, okay, but like, when am I going to use this? Thinking that just this stuff happens only in, some kind of lab with like a white coat and safety goggles on. But here's one place that we actually see some acids and bases chemistry happening in real life with having major effects are our oceans. Okay. But before we get to the oceans, we're going to have to like take a moment and start on the land and in the air. And we're going to have to look at humans and some of the things that we are doing. Now, humans do lots of things on land, but one of the things that we do a lot is we burn fossil fuels, okay? And things like gasoline, that's a fossil fuel. So whenever we drive our cars or use anything that uses gasoline, like an airplane, okay, that's burning a fossil fuel. Our electricity is generated in power plants. Oftentimes those power plants are coal burning. That's a fossil fuel. Things like heating our homes in the winter with natural gas. That's a fossil fuel. Cooking on stoves with like the blue flame, right? That's a natural gas. That's fossil fuels, okay? So all these things are things that like came from the earth that we've dug up and have discovered that we can burn, okay? And as it turns out, when you burn a fossil fuel, it releases carbon dioxide into the air. Okay, so here is a nice little graph showing you in blue, this is how much CO2, how much carbon dioxide is being emitted, okay? And the pink is how much we can measure in the atmosphere, okay? So a couple things I want you to note for this. First of all, this goes all the way back to 1750, okay? And so notice that there is carbon dioxide in the air, right? Always. There's always CO2 in the air, okay? That's normal. But notice how we've had this like increase that has gone up, and it's really, really started to go up, like especially like industrial revolution here happening in the 1800s started to increase. But then right in here, this is when everybody started getting cars and airplane travel started happening. And notice all of this huge, massive increase, right? Both in atmospheric CO2 and in the emissions. That means like what we are releasing into the atmosphere. Now, some people might say, okay, well, sure, that's just like a little bit of a graph. Like, what about the rest of it? Because like we've had, like, isn't this normal for things to go up and down? And I'll say, kind of. We actually, by going into ice cores of glaciers, we can actually measure the carbon dioxide levels back like 800,000 years. And if you take a look at this, this should be pretty interesting because notice there's big ups and downs here. The CO2 levels are not constant throughout the world's history. And obviously humans were not alive during this. So there is a natural fluctuation in CO2 levels that is to be expected on Earth, okay? Things fluctuate. But look over here. So right here, 1800, this was kind of, one of the natural highs that sometimes we get. And here's 1900, and here was 2016. That should stand out to you, right? This is higher than it has ever been before in the past almost million years, right? And this trend has continued to go up, and every single year it keeps getting higher and higher. We're not dipping back down yet. So CO2 definitely on the rise, and definitely on the rise outside of what's considered normal for Earth's history. Okay. Now, in our air, like I said, there's always CO2. And in fact, the air that we breathe is made up of mostly nitrogen. And then, about 21% or so is oxygen. And we've got argon, we've got other gases, and notice CO2 here is only 0.03%, okay? So actually, there's not a whole lot of carbon dioxide in the air. However, as we burn more fossil fuels, this teeny tiny number is going up and going up and going up. And that might not sound like a very big deal, but we're gonna see how this is going to have an effect on things, okay? Okay, so now let's go back. We're gonna kind of go back to the oceans now for a second, right? There's so many different things that live in the oceans, right? We've got whales and sharks and seahorses and starfish and eels and all these things. And one of the ones you might be most familiar with is just like fish, okay? Or really most living things that live underwater. How do these things live underwater without breathing? I'm sure a lot of you know that fish have gills, but like, how does that actually work? Okay, so what happens is fish take in water through their mouth. You might notice when a fish opens its mouth like that, if you've ever seen any goldfish. And what happens is the water goes in its mouth, and then the fish doesn't swallow that water, it moves it over its gills. Okay, and what happens is these gills basically act like your and my lungs. You know how we breathe in? And our lungs are able to take the oxygen out of the air because, as we just saw, right, air is mostly nitrogen. So our lungs are able to take that oxygen out of the air and put it into our bloodstream. Well, that's what a fish's gills do. They take the oxygen out of water and they put it into the fish's bloodstream. Okay, pretty cool. So obviously oxygen has to be in the water in the first place. And I know water is H2O, but that oxygen is bound up in a molecule. So that isn't the type of oxygen the fish can breathe. They're breathing dissolved oxygen. They're breathing O2 that is dissolved in the water. Now, there's lots of different ways that oxygen can get into water, and we're not going to go into all of them. But the main things that place oxygen into water would be any plants that are living in that environment doing photosynthesis, which hopefully you know that photosynthesis releases oxygen. And the other way that oxygen and air gets into the water is wind. Okay, so wind churns up the surface of the water, creates waves, and that ends up incorporating the air that dissolves into the water. Okay, so now we kind of know about like some gases in the air, and we know about some gases in the water. And so now we're going to finally put those two ideas together and see how this is going to affect our oceans. So as we know, we've got more carbon dioxide in the atmosphere, okay, because of burning all those fossil fuels, which means when that air gets mixed into ocean water by wind and storms and waves, we're going to get more carbon dioxide in the oceans. And when that carbon dioxide dissolves in the ocean water, here's the reaction that happens. CO2 plus H2O makes H2CO3. What kind of compound is H2CO3? What does it start with? H. Ooh. Oh, so that means it's an acid. How do we name that acid? You would check your polyatomic ion sheet for CO3, which is carbonate. So this would be carbonic acid. Okay, so when carbon dioxide gets dissolved in water, it forms carbonic acid. Okay, so the more carbon dioxide that's in the air leads to more in the oceans, which means this leads to acid forming in the ocean. So this is called ocean acidification. Okay, and what do we know about acids on the pH scale? Well, what's neutral? Hopefully you remember that neutral is 7 and that acids are something lower than that, okay? And so if we look at this graph right here, okay, this is showing, this is measured from like a volcano in the middle of the ocean, which is a really great place to measure atmosphere stuff because it's not affected by like major cities or anything like that. So here are the CO2 measurements, okay, since roughly 1955. Notice general trend going up, lots of ups and downs, but general trend going up. This is the dissolved CO2 that ends up in the ocean water, again, by this volcano, by this volcanic island. So again, lots of up and downs, but generally going up. But here is the pH of that seawater. Ooh, notice that trend is going down. This should make sense because if we're adding more acid to a thing, its pH should lower because acids are lower on our pH scale. And notice that if we look at this over here, ocean water is a little bit basic. Okay, so naturally ocean water is basic, but as we get that carbonic acid in our oceans, that pH level is slowly going down. And that might not seem really big, but in fact, a change in pH like that ends up having really, really big consequences, okay? This small change in pH has already started to dissolve the shells of some oceanic animals, okay? It's also causing the coral reefs to die off at a rapid rate as well. And of course, we rely on things like the ocean for things like food and recreation, and lots of economy can be tied to that. You know, fishermen, people who go scuba diving and tourism and all that kind of stuff. And so this is actually having huge impacts, not just in the people directly around the coral reefs, but like far-reaching impacts. So next time we're going to see more real-life examples of how the oceans becoming acidified are affecting the animals and the humans.